Hello Math 8 students, this is Misty Witt. Today is Monday, February 28th. We are going to be taking notes on the start of chapter 8, looking at simple interest compared to compound interest and how that affects an amount. So John needs to borrow $250. There are two places he's looking to borrow from. The first place has an 8% simple interest each week. The second place has a 6% compound interest each week. So compound interest and simple interest are calculated a little bit differently. Simple interest is calculated by taking 6% of the original amount, so 6% of 250, and then adding that amount every week. So to find that, we would do 0.06 times 250. I'm sorry, when I say, I should be saying 8%. So it should be 0.08. And that is going to be $20. So basically, they are adding $20 to his savings account each week, and that would continue on for 12 weeks. So go ahead and fill in the rest of the table. So after 12 weeks, he will have $490 based on the simple interest bank account. The other bank is offering compound interest, and compound interest is a little bit different. Compound interest takes 6% of what your current interest is that week. So to calculate, so it changes every week. So the more you save, the more you earn. So they calculate that by multiplying the current amount by 1.06. That is the current amount plus the 6%. So in order to get the next week's amount, they multiply it by 1.06 and then add it on. 1.06 and then 1.06. So if we were to multiply 297.75 times 1.06, that would be $315.62. And then if we were to multiply that by 1.06, we would get $334.56. So I'm going to fill in the rest of these. Follow along. You can multiply to find the amount, or you can follow along with me. 398.46, 422.37, 447.37, 474.57, and then 503.05. So at first, it's actually better for us to save our money with the first bank using simple interest. So let's make a graph. So we started at $250 and then we went up $20 every week. And so I'm just gonna do a very rough sketch using my ruler. I'm gonna draw a line. Let's draw a line there. And then, but with the other bank, I'm gonna just change the color so you can see it. We also started off at $250, but our amounts are actually less. At the first week, we were at $265, a little bit less. And our bank ends up looking something like this. So right at about 11 weeks. It goes up, and at about 11 weeks is where it passes it. So it's something like this. And so it's not linear. Our simple interest is linear, but the compound interest is not linear. So it asks us which bank will charge him, which bank will charge him more if he pays the loan back in 12 weeks? Should he choose the same bank if he plans to pay it back in 4 weeks? Well, if we look at 4 weeks, he's only going to have to pay $330 back to Moneybags, but he's going to only have to pay $315.62 to the Scrooge Savings. Compared to 12 weeks, he has to pay back $490, but then the other bank is $503. So the Scrooge bank will charge more, which is the compound interest, charges more at 12 weeks, but Moneybags, which is the simple interest, charges more at 4 weeks. So making that table actually was really helpful. Simple interest is an example of linear growth. We mentioned that by noticing the straight line. And compound interest is an example of exponential growth. We noticed that by it's a curved line. Talk with your team about how you could explain to someone else the difference between these two kinds of growth. So what I noticed about the simple interest, we definitely noticed it was linear. It was a straight line, and it's adding the same amount each time. So whether it's weeks or years, it depends. The compound interest was nonlinear, and it was what we call an exponential growth. And we noticed that it was not adding the same amount each time, it was multiplying the same amount each time. So that was the big difference. One was adding, one was multiplying. Go ahead and flip your document over for me, please, after you get that copied down. So Mariana is curious how much money she will have in her account when she's 18 and graduates from high school. She looks at a table she created, and she looked at the numbers for the first two columns. That's years and balance. She noticed a pattern that she thought she could rewrite into a shortcut. Study the table. So what do you notice? It looks like she starts with 500, and then she multiplies by 1.05, and then she multiplies by 1.05 again. So it looks like what kind of interest is she has? Well, I noticed it looks like she has compound interest because she is multiplying each time. And to me, because it's 1.05, it looks like she's got a 5% interest each time. So how could you rewrite Mariana's balance at the end of any year in terms of principal? Her principal is $500, and let's write it in some sort of an equation. It looks like we could do, we could do 500 times 1.05, and then there would be this X here, where X is the number of years, because after the first year, it was 1. After the second year, we multiplied 1.05 twice. After the third year, we multiplied 1.05 3 times. So X is the number of years. Sometimes we write that as T for time. So based on the pattern, describe how you would find Mariana's balance after 18 years without first finding the balance of 17 years. So we would take 500 and we would multiply 1.05 18 times. Now, I don't know how to do that without a calculator. So what I'm going to do is I'm going to do 500 times 1.05 to the 18th power. Now, first I need to do 1.05 to the 18th power because order of operations tells me that I need to do that exponents first. So 1.05 to the 18th power, I'm doing that on my calculator. You can't see that off screen. So 1.05 to the 18th power is, sorry, hold on one second, 1.05 to the 18th power is 2.406, and it's repeating. So we're going to round that to 2.41. So we're going to do 500 times 2.41, and that is going to be 1,203.31 cents. It's a lot of money. So she's saving, going to have a lot of money saved with her $500 deposit. So the pattern you described in words in part C for 8-15 can be rewritten in symbols. So we wrote that as exponents. With the exponents 4 to the 5th power, I want you to note that the 4 is what we call our base. It's what we multiply. And 5 is what we call our exponent. So we multiply 4 5 times. So write the numbers you multiplied in part D of problem 8-15 as an expression using exponents. And so that's actually what we just did. We did 500 times 1.05 to the 18th power. We did to the 18th power first, and that's how we got our answer. Okay, so we're going to do the same one. Why don't you guys try this one? You try B, and I will do it for you, so you can pause the video. A comic book is purchased for $6, so the principal is 6. And it is resold 7 times, and each time it is resold, the seller charges 15% interest. So we would do 6 times 1.15, and it would be to the 7th power. All right, Math 8 students, go ahead and check your playlist for tonight's homework and email your teacher or ask a question if you have questions